Next problem is called best time to buy and sell stock. We are given an array of prices where each element is basically a price of a given stock on the ith day. So if you're checking for the second element, basically that's the price for the seventh day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. We have to return the maximum profit we can achieve from this first action. If you cannot achieve any profit, we just return a 0. Basically, this is our initial max profit, the max profit that we can earn before we are even traversing the array and checking the prices. It's basically nothing. Now, the single most important constraint of this problem is that we have to first buy this stock in order for us to sell it. Now the constraints are also the length of the elements, length of the prices that you are getting. Here they are from 1 to 10 to the 5th. So we are looking for a linear time complexity algorithm, and the prices are ranging from the 0 to 10 to the 4th. Now, if we can easily solve this problem by just checking for each price in the array, just checking the maximum profit that we can achieve by combining that price with any other element inside the array, and just checking the differences and tracking the result. That would lead us to a quadratic time complexity, because we will be comparing basically one element with the rest of the rest of the array, and so on. So they are that leads us to a quadratic time complexity. But the thing is that we have to first buy the stock before we sell it. So for each day, let's say for the day, for this day where the price is 6, we are not interested if you are selling at this point. We are not interested in anything after this, anything in the future. We are only interested in the minimum price that we have seen so far in the array before reaching this element. Because the maximum profit that we can do is basically subtracting selling at this point. So subtracting this value from the minimum value, our selling point, in this case 1 is the minimum value, and basically the reward that we get, the profit that we are achieving, is 6 minus 1, and that's equal to 5. So basically, there are only two things that we have to do. We have to traverse the array, and we will keep the local minimum price. And if I say local minimum, that price might not be the minimum of the whole array. It's just it's just the minimum up to the element that we are currently observing, and we will use that minimum to basically determine the maximum profit that we can reach for any certain day. Because we are only traversing the array, we will have linear time complexity, and we will not build any additional data sources, so we will have constant space complexity. So the initial value of the max profit will be 0, and the minimum price will be set to the largest integer value, so it can be reset when we visit the first element of the input array. Next, we will traverse the prices, and basically we will do two things. We will first check what's the minimum price. Can we update the minimum price up to this point? So we are looking for a local minimum by just comparing the current minimum price and also the price that we are currently observing. If the current price is smaller than the minimal price, then we just update the minimal price to reflect that. Next, we will check if we can make a larger profit by selling at this certain point, and if you're selling at this point, the reward is basically the current price that you are observing minus the day that we bought the stock, and the day that we bought the stock is basically the day when we had the minimum price per minimum price stock. So we just subtract the minimum price from the current price to get the maximum profit that we can earn by selling at this day, and we check if we can update the total max profit that will be returning as the result of our function.